All right. Since we have a lot of people in, we'd like to begin today's proceedings. I'd like to introduce Janit Gunasekar to you. He is the Director of Quality Engineering here at Cisco Labs, Sri Lanka. Janit, over to you.
Thank you, Baba. Good evening, everyone. Welcome to Perf Up the launch. This event is powered by Cisco Labs and LMD as the media partner. And thank you very much, Cisco Labs and LMD for powering this event because these type of events are really important for us to gear up for future work. And before I go into today's session, I would like to talk about this Perf Up. What is this initiative? So this is an initiative. What we thought is to bring up the industry experts on performance engineering, talk about and their knowledge and share their knowledge, their experience, and their predictions about the future on performance engineering to the industry. So it is a initiative where we take from the industry and share to the industry because we believe that all together we can grow as an industry because it's really needed and then we can definitely gear up for future. So there will be a lot of sessions under the PerfUp initiative. There will be a lot of topics that we are going to share from the industry experts, and definitely we can gear up for the future. With that, we thought that kicking this perf up for the launch, the panel discussion would be ideal so that we can talk about this initiative a bit more and try to understand uh, what is this perf up is all about, and then we can go into detail in later sessions. So in this panel discussion, we thought our topic should be something like this. The topic is transformation from performance testing to performance engineering. So we all know about performance testing and tools and all. So in this session, we are going to talk about uh, what is the transformation or why the transformation is needed from performance testing to performance engineering. To talk about that, we have a panel, and let me introduce the panel to you. Uh, First, I'll introduce Dilhan Manwadu. Dilhan is the Director Development Platform at Cisco. He brings over 14 years of experience in software development industry, especially with large multinational organizations. He holds a PhD in information communication technology with specialization in software development methodologies from the Management and Science University, Malaysia. Then we have Rohan. Rohan is the Vice President Engineering and Architecture at Cisco Labs. He has over 15 years of experience in engineering highly scalable client server and consumer application in capital markets, finance services, banking, and healthcare. And also he has worked with many startups. Rohan has a BSc in computer science and engineering from University of Moratuwa. Then we have Suraj Ribera. Suraj is the lead performance engineering at Tata Consultancy Service. Suraj is an experienced and specialized performance testing and engineering resource with over 11 years experience, and he has delivered multiple projects successfully in different geolocations, and also he has worked to improve end user experience as well as optimum server utilization of multiple applications which were developed in different technologies. And I'm Janit. I'm the moderator for the session, and I'll be moderating the questions with the panel and with you. Um, so, panel, welcome to the session, and audience, welcome to the session. And there are two ways that you can engage with the panel. One is that you can use the URL shared in the screen right now. You can click that and post your question, and we will be asking that question. And then there's another option that you can use the WebEx hands up option or raise the hand option. You can raise it hand, and then you can unmute and ask the question from the panel once I directed the question to the opportunity to you to speak out. That's how we thought that we can engage, and please prepare your questions and clarify all the doubts that you have about this, and make use of the time and ask all the questions and keep on coming these questions, and we will try to take it up while we are going on rather than waiting for the last part of the session to discuss about questions. That's all about the lineup and how are we going to do that. With that panel, I would like to start the question from me. So we were talking about transformation from performance test to performance engineering. So the first question goes to Suraj. Suraj, what is this performance engineering? Is it same as performance testing, or is there a difference? What's your thoughts about that, Suraj?
Opportunity, and let me give you, share some knowledge and expertise that I have for you to, improve yourselves. And, as Janit asked, and this kind of a question a lot of people ask, especially in the testing area as well as engineering area. So if we, in mainly in performance engineering, we conduct our, general performance testing activities and all, and we mainly, go for analyzing potential bottlenecks, and we are trying to figure out what is blocking our stability, reliability of the application. And key thing here is like we are doing all these things, all these engineering activities, all these testing activities with the mind test of tweaking and tuning, that is for the better behavior. And if you are talking about main differences, okay, so sometimes we may do same thing in performance testing, some of the things, but the objective of all these activities getting different. Okay, and also the phases and also like life cycle of these activities getting changed. So in performance testing, we mainly talk about, okay, we have NFR, then we are validating against that, we are certifying based on that. But in performance engineering, it can go up to components or features designing, up to the tweaking code or infrastructure to make sure that we are delivering a reliable and scalable application. So I know we have some participants who have just started their career, and they have no idea. They might not have an idea about the performance testing and engineering. The best simple way that I can put, like suppose you are given a suppose in the practical way we can put, like suppose if you have given a bat, we all know cricket, right? So suppose you have to certify the cricket bat which has to be used by Sanat Jayasuri or Chris Gales, because even though it is functionally validated, height, width, and everything, but it has to, that players should be able to use those bats to hit bigger shots, continuously do more and more shots. Then that means we are checking for the behavioral factors. Okay, in testing, we may, like if we talk about only testing part, we are talking about, okay, whether we can hit multiple shots with this, we consistently we can use this, how long we can use this and all. But when it comes to performance engineering task, we started to look into, okay, how well it is doing, and if it is not, if we can't use that bat to our application, we started to figure out why and what changes we need to do. Likewise, we, if you are a beginner, you can map that type of a behavioral aspect, anything in your performance engineering. So that is the simple way I can put it.
Right, Suraj. So I think it's a good start. Talk about what is performance engineering is all about. Then I would like to direct the same question to you, Rohana. So from your thoughts, what is performance engineering?
Yeah, Janit, I hope you can hear me.
Yes, loud and clear, Rohana.
Good evening, everyone. And first of all, thank you, Janit, for leading this effort. I think having a focus group of people and set of sessions is something that is required by Sri Lanka, like as an industry, to focus on the performance engineering. So, I mean, let me talk about the performance engineering and testing. I think there's a clear distinctions between the two. Typically, performance testing happens at the end of a product development and focus on ensuring that it has the required performance. But in order to get to that level, you have to first engineer the solutions with performance in mind. Right? There are various practices that we can apply, various engineering theories we can apply. If you haven't applied those in performance testing, you will see bottlenecks. And some of these bottlenecks going to cause big delays in your projects, or utter failures in your project sometimes, and you may have to go back to drawing board and come back with some new architecture or pattern. So I think typically in the industry, at least in Sri Lankan context, performance testing has been very common. But whether we pay sufficient attention to performance engineering is a question. I think sessions like this will help make that awareness. So in performance engineering, what we try to do is to engineer our solutions, architecture, design, and development, and then verify that the solutions we build meet the expected performance or exceed the expected performance, right? So this involves a lot of effort, kind of an umbrella activity in the software development lifecycle, and everybody in a development team can contribute to this activity. Unlike in performance testing, where QA is typically focused on the aspects of testing. So if you look at even from the end users, now people are more educated about the performance and the expected performance, so they may give the first-hand expectations that they are expecting, looking at their competitions and all that. Then the product owners, they have a huge role to play in performance engineering to understand the required performance, or at least be curious about it, and probably educate even the end users, right? Because setting the stage for the rest of the development is very important, and that's where a lot of the time people struggle with buying time and spending time to engineer solutions. So having product owners focus on performance will help set that stage for the rest of the team to deliver. Then if you come to UX and engineer, right, and he has a role to play. How do you lay out your applications, be it a mobile application, be it a web applications? Your layout of the application matters, and how do you want to interact with the users matters. What sort of resources you download your device matters. So he has a huge role to play. It's not just about the artistic ideas, but understanding the efficiency of how you implement those solutions also come into play. Then comes the architects, developers. We generally call them developers, and probably they are the biggest contributor in getting a product engineered for performance, right? Because they contribute in the design, and they write the code, they write the SQLs. Every piece of code you write, every piece of SQL you write, every piece of data you send over the network, right, matters for performance. And then the testers, right, instead of contributing at the end of the cycle, it's important to give their feedback at the beginning of our development cycle, right? So that way architects will be more knowledgeable and developers will be more knowledgeable, and as a team, people will understand the expectations and will pay more focus. So in software engineering, it's a kind of an umbrella activity that everybody can contribute to, and also it's a practice where you can put your engineering theories, engineering knowledge into practice.
Right.
I could give a sufficient satisfactory answer.
Yes. I think it's a good starting point, Rohan. Definitely, we can discuss more in follow-up questions. So now I would like to move the focus to Dilhan. Dilhan, so for you, what is performance engineering for you, Dilhan?
Right, Janit, I'm audible, right? Just want to double check before.
Yes, loud and clear.
All right. Okay. Again, good morning, good afternoon, good evening to everyone. Thank you for all joining. And again, Janit and the team, thank you for organizing this and having me as well. So great answers from Suraj and Rohan. And I just want to have a different perspective, and I'll just share from a high level business and more of a delivery perspective. So think like this, right? Today we are in a digital economy, and technology is disrupting everything, right? There is no more where the business gives orders to technology and we do something, but it's basically all the technology companies are basically creating businesses, right? So in this digital economy where humans and consumers are craving for instant gratification, right? So today like if you want something, you just need it. You can just download. You don't need to go to the bookstore to buy a book. You can just download it and read it. And if you want music, you can just get it as well. If you want something, you can get it next day shipped to your house. So instant gratification is really, really high among consumers. So just think, right? Like if your consumer, the user of an application or a business user, whoever, who comes to your application or mobile app and has to wait for like 10-20 seconds to get it load, or for the recommendations load or the images load, I mean, they're just going to go away, right? Just think about the same thing that you have faced when you launch a website. It doesn't load, maybe because it can be because of internet connectivity, but then again, it just frustrates you, right? So basically, in my opinion, Janet, like I feel performance engineering and the need for it and everything is that, right? The user, the instant gratification that people need today is actually the need for this, and the performance to be even higher than before. And one thing that we've also seen is now, because business users are also consumers of apps like Amazon and Apple, they are also needing the same level of magnitude from their business apps as well, because at home they use Amazon, but now in their workplace maybe they have things slow. So performance engineering, in my opinion, is that solving this problem and building highly scalable, highly available solutions, which lead to better performance in an application UI or whatever the stack. And then basically the development team, the architecture group, and everybody working together, shifting left from the start of the application, right? Defining this criteria and moving forward. It is very frustrating sometimes. We always think, we should get a NFR from the business, like non-functional requirement, all that, but basically it's not that. We have to work as one group to develop a product with the non-functional requirement aspect, and then engineer that solution, as Rohan and Suraj mentioned, to get it out there. So basically, that's what I feel, thinking big of that consumer who's using it, and then taking it. So, and then to your question, performance testing, basically performance testing is just enabling it with certain testing methodologies and tools and practices. So that's what I feel, Janet, in my view.
Good, Dhiran. We talked about three panelists. We were talking about three different aspects, right? From overall QV starting point and the development, other roles, as well as from the business and delivery. So my next question is to you, Rohan, because you mentioned that development or developers or engineering or engineers, they will be one of the biggest people who are involved in performance. So I would like you to go into little bit of details about, as a software engineer, what we need to think or get ready as performance engineering, because you are an expert and a very experienced person as a software engineer, right? So Rohan, over to you.
Well, when it comes to performance engineering, I think this is a discipline that is practiced in multiple engineering disciplines, right? I mean, there are practices in civil and aviation and any sort of engineering and computer engineering as well. But typically, I think there is a lot of focus. There has been a lot of focus in performance engineering when it comes to designing a computer and memory system, the CPU, and all of that, right? So with those understanding, something that as developers we need to understand is, okay, everybody loves to have the best performance, and they will be craving for everything to be fantastic, and it's easier said than done. So as developers, we need to while we know there can be improvements to the engineering by applying certain theories, there are certain limitations that we will have to live with. For example, maybe our processing capacity is limited and our memory is limited, and storage may be limited, right? So, and network bandwidth could be limited. So understanding those limitations also is very important under the context of when you develop or design your solutions. And having this in mind and knowing the expected performance, you need to, a lot of the time you have to make trade-offs. You have to make decisions, right? In order to make those decisions, it's really important our engineers know about the performance implications of their coding, choice of their technologies, and also be able to get an immediate feedback on some of those selections and trade-offs, right? So unlike in the past where we let QEs or some other organization to focus on the performance engineering or performance testing at the end of the cycle, now developers have a challenge to do these experiments themselves or use some of the utilities or some of the tools supported by your QE organization to get immediate feedback early in the development and iterate over that and make decisions based on data, right? So developers need to be able to understand and measure the performance. So these are some of the areas that I think people sometimes lacking. Being able to measure the performance, how do you measure throughput? How do you measure the concurrency? And the implication of those high-end operations and how you need to organize your code and the architecture. There are a lot of available technologies today and architectural patterns and design patterns. But they all like maybe from theory, certain theories like, we have this theory of batching, right? You can batch certain operations. So those are very basic theories when it comes to performance engineering. Fast path approach where you try to cache some of the items, you observe workload properties. For example, how you observe certain requests that are coming to your server and figure out, okay, what are the more frequent versus what are the less frequent. Then you optimize the way you organize those code bases to make the end users feel that the system is performing well, right? So I think as developers, it's important to understand these limitations and the expected performance and make the trade-offs with data and be familiarized with these different testing tools and collect data and interpret them and because performance engineering, if you look at, is a kind of an iterative thing, right? I mean, you may not be able to design the solutions right at the first stage. It needs to be iterative, and as developers, we need to make sure our development environments, our development platform supports that iteration and doing quick changes. So I think that is where we need to focus. And also sometimes we may be misled, right, with a lot of the architectural patterns available today, like we have this microservices based architectures, distributed architectures. Some are counterproductive to production. So you need to strike the right balance of choosing that, and that being able to iterate over your findings and tune your application is a key to get this engineering implemented in your solutions.
Okay, got it. Rohan, I think now it's clear that performance engineering, when it comes to development or engineering, there are a lot of things to think through when you are designing your application, when you're doing the development, different things to consider. I think now it's clear from the development perspective that there are a lot to think about when we are developing a solution, irrespective of the size of the solution. So with that, I would like to direct the same question, but from the quality engineering perspective to Suraj. Suraj, now you have experience as a performance testing and performance engineering. So from the quality engineering perspective, we were talking about testing. Dilhan talked about testing is an enabler for performance engineering. So can you elaborate a bit more in performance engineering practice, how the quality engineering activities will impact or will change? Can you elaborate a bit more on that aspect, Suraj?
Yeah. So basically, we all know the simplest thing we do when we are, if you're a performance tester, is like you may using a load runner or may using a JMeter or some other tool, just to generate the load and check the response times and other, performance testing related, counters or KPIs. Okay. But when you're talking about the moving from performance testing to performance engineering, to be honest, like it makes our life more, working life more complex and challenging. But I see it, it's a very interesting shifting, because in performance engineering, okay, so instead of assessing and communicating that we have a bug or issue against our NFR, okay, we started to dig down more, okay, and we try to investigate further, and we are trying to identify the potential root cause which which has blocked your better performance, okay. So and especially the good, sometimes we even start to try out different solutions, like maybe it's a config change, and there are code changes even we are trying, because if we see kind of some issue with some loops, we can also tweak that, or else we may be talking about doing some infrastructural change. We those changes we categorize into vertical and horizontal changes. So likewise, for me personally, I see it as a very interesting thing, and sometimes it becomes challenging, but it is very good. And if you're talking about a very very mature projects or mature company with performance engineering, okay, then we start to involve ourselves even in component level designing, as well as validating the early stage of it. And also right, we have shift left and shift right practices, like we are integrating with the continuous integration, and we are using all the things in production monitoring, and learning things, what changes we are doing and all. So those are the main changes, interesting things that I see. So for the people who just started to know about the performance testing and all, and if I go for the same example that I started with, like I was talking about how, certifying the bat that has to be used by Chris Gales or Sanat Jayasuriya, right? So that names also brings tell you, okay, those bat has to work properly. If they are hitting the balls for 60 balls, that bat should be strong enough, as well as should be able to survive and all. So in engineer, if testing, yes, I said, like we are checking, yes, okay, whether it can hit continue 60 balls with surviving. But if you are talking about performance engineering part, if I elaborate more, like in video games, we have seen like quality of condition of, if you have, I think everybody has played video games for, and maybe car race, NFR games, sorry, Need for Speed games, right? So in that time, you can see, some areas are not good. Like it's test wise, you will start to see. Likewise, suppose your bat is, we are monitoring this test as engineer. Okay, then we are going to see. Then we are seeing, okay, if the quality of the bat or the survival of the bat is going down. Okay, and then like those are the things, from tester to engineer, we do more monitoring, and also we have started to drill down, trying to figure out, okay, before it breaks. Okay, like instead of thinking in reactive way, we started proactively. Try to see, okay, what things we have to keep eye, and what things we have to validate, what we think we are doing in advance. Okay, so if I move that example into our code, in our application, web applications or mobile apps, we started to drill down in our logs. We are trying to there are specific tools that we are going to talk about later, but we are trying to use all these tools, like to see behavioral factors and issues that we can figure out based on the logs and all, or the monitoring tools. Those things make your life easy, in performance engineering. And also it's very interesting, and it is very challenging.
Right. Awesome. I think now from the quality engineering perspective, we heard what performance engineering means, and then in future we can talk about some adaptation and practices and all. With that, I would like to now move the focus to Dilhan. Now, Dilhan was talking about from the delivery perspective, business perspective, or the enterprise perspective. Can you go a bit more into detail about performance engineering in business delivery perspective, Dilhan, and like enlighten the audience on some of the experience that you have?
Yeah, sure. So I would say just thing, right? It's critical, right? Because from a business, from a delivery point of view, if somebody's lead from a business who's accountable for stakeholders, right? It's mission critical. Why? Because digital products, drive business arm. So You cannot just have a low performing application and try to drive a business. Simple as that. Think about your banking app, and if it doesn't work, right? I mean, if you cannot get your transactions done, you will basically, switch your bank. Today, banks are actually technology companies, and they are not just banks, right? So if you take that concept as an example for delivery and business, it's mission critical. And because it's technology is dominating, right? And I would say having that mindset and delivering those applications with high performance is mandatory, and it's not an afterthought. Technology, my strong belief is these always go to leadership and people and all the stakeholders who are in it. But what I feel is with past experience, technology needs kind of lead it and influence it rather than again waiting for somebody else to say, because you have to be very careful as well, because you may do a product, right? May do a product with an MVP approach where you will, use the MVP to iterate. So if you do not just look at performance, just do a very not a good scaled and available application, your MVP might get attraction from customers and then it might go blow off, right? So if you don't think from the start, from a business point of view, you're going to get in trouble. Unless you're doing a POC, which just a survey thing, which will not iterative, I think you need to start thinking that. So I think, Janet, basically from a business point of view, it's mission critical. It has to be baked into overall strategy, what I believe.
Right, Dilhan. So now it says that performance engineering is not just one single activity. It is an umbrella where there are a lot of roles and different people are involved in. We need to start from the early as much as possible so that you can make sure that performance is baked into the product so that you will be having a successful product. So Dilhan, I would like to keep the focus with you and extend that the question from the delivery perspective, the agile methodology, right? So most of the modern organizations, they believe in agile philosophy or agile principles, and then they try to adapt it to their organization. So from your experience, how performance engineering will fit into the in the agile philosophy or in agile practice?
Right, Janit. Again, I alluded to this earlier as well. For agile delivery, successful, the people, leadership, everything matters, right? That's the mindset that you need to have. But keeping that aside for the moment, I think from performance any point of view, how can fit the daily approach is if you're on like a sprint base or a Kanban base activity, you might want to think of more incremental iterative approach, right? Because you cannot think sprints and then wait till the sprint before pushing to production performance testing, right? So that doesn't work. Think of that, and then I mean a recommendation for somebody who starts, and this is something we've done, experimented and done multiple times, is think big in terms of the architecture and certain things like NFRs at the start, because you cannot just slice these things and you can't just discover things along your way. So think big at the start where you design your architecture, but when you implement, deliver it in small slices. So as example, if you really look at certain things like performance testing that you need to do, incrementally bake it in your stories, right? One recommendation that we have done and we are doing is that the team is pushed to kind of, again, when I say pushed, it's more evangelized to get their DOD, right, done in terms of having performance also part of their user story acceptance. Because at the end, the quality matters as they do testing, they do CI/CD, they performance, or how do you do that? But you cannot do that if you architect it the start, because it's not easy to do performance, right? So that's one recommendation, how you fit it. And the other thing is sometimes, like I mean, this may be another future question. technical wise, you cannot just try to think performance and do it. You need to have tooling and need to have all this infrastructure we'll talk about in the future. So get that started upfront as well, because otherwise your team will not be able to deliver in sprint. So anytime in a sprint zero or something, before you start, lay out everything and then go is one of my recommendations to keep sustainable, Janit. We have to have a mindset of iterative and incremental evaluation, and also baking those things, attributes into your DOD and sprint level, so that the team commits, right? So those
we talked about. So the first question I would like to point it to either Rohan or Suraj. I think you can jump in and talk about it. The first question is that in modern testing, now we are more focused on testing as early as possible to reduce the work and rework and the cost. And how shift left applicable to performance engineering. So I would like to modify this a bit. Since Suraj talked about the quality engine perspective, Rohan talked about from the development perspective, lift shift is an approach where it is applicable for the engineer, right? Both sides. So how the question is again, in modern testing, now we are more focused on testing as early as possible to reduce the rework cost, and how shift left applicable to performance engineering. So left shifts, right? So how it is applicable from the engineering and the development side? Quick answer for that question, Suraj and Rohan.
Yeah, so basically, if we take your application, right, any application, right, if we are testing at the last minute and if we find any performance issue, any bottleneck, okay, so sometimes that can be easy fix, but most of the time it is not. So performance testing and performance engineering, when we are doing, right, we realize, okay, sometimes we may have to change the architecture of it. Sometimes there are sometimes it lead us to stop the production release as well. Okay, so if we that means that point us to a portion level where, okay, we have to think about this performance testing and tuning and everything in advance. So shift left, with the shift left we are talking about, okay, doing the test as soon as possible. That is one thing. Like, that is why we are talking about CI/CD integration. When the deployment happens, it can be connected to Jenkins and all, and we can automatically run our test, and reports can be automatically generated. Then it is kind of we are reducing the lead time of testing and all. Other than that, actually, one like I think one part even Dilhan covered, like in agile world, right? So when in agile we are building up something in incremental way. Okay, so when in the user story level, then when features are coming in, okay, in the same story, we can define the definition of done, and the way we are certifying that story, then performance factors come in the fair, points come in there. For an example, you have to create page load, or you may have to load some data. In that one, you have, okay, in a forest 3 seconds, and it should not be having this greater than this size of it. Okay, likewise, that means now in the early stages, in the small component level, okay, we are certifying and we are validating. So because of that, when it comes to the large big product, we don't have those bigger performance issues. So that likewise, when we are shifting left and we starting things in advance, we can we can handle the performance issues earlier in the life cycle.
Right. Rohan, would you like to take a minute and share your thoughts on this?
Yeah, probably my 2 cents, right? Let's look at why performance engineering is stayed on the right side of the development life cycle, right? because QVs did not have the trust on the development, and they did not know what was being developed. And they wanted, because based on the past experience and perceptions and all of that, they wanted the development to be completed before running a performance testing. And that is one reason. There is another reason why it stayed in the right side, because performance testing is very costly, right? And doing that iteratively was very costly. Maintaining the environments require a lot of efforts, and it probably requires a lot of money as well. But with the advancement of the technologies nowadays, especially with cloud computing, I'm sure a lot of the organizations, we have participants from are utilizing or are benefiting from cloud computing. Or maybe they have their own data centers still having features that are available in today's dynamic cloud computing. With that infrastructure advancement, I think it has made it possible to spawn up these environments really quick and run your tests just for the amount of, or for the period of time you want it, and then shut it down. That way you have very cost-effective solutions if you were worried about certain environment-related complexities. With infrastructure as code and CI/CD tools and DevOps capabilities, you can automate a lot of this testing early. Then the trust about, okay, do we need to wait until everything gets completed? I think it requires a lot of collaboration between QVs and devs and working as one team. I think Agile fosters that culture. And we know, like, if you look at a lot of the other engineering practices like functional testing, test preparation, or test planning, test designing is happening very collaboratively, I think, in a matured Agile team. So that needs to be extended to the performance engineering as well. I still feel there is a lacking collaboration when it comes to performance, but I think being more collaborative and giving that understanding of the architecture and the technologies behind the application to the QVs will help them do the testing at unit levels. Maybe the initial testing we can get help from the QVs to even run some database scripting related testing, right? And choose that technology so they feel more and more comfortable about what is coming that way.
Okay.
At the same time, I think developers also need to contribute to the same test suites. Typically, the performance test suites are being maintained by QVs and development done by developers. But I think, especially when it comes to testing, it needs to be a shared code base where people, get with high visibility and everybody can contribute. With that way, I think we can start some of this testing early. And a lot of POCs you do upfront is going to definitely benefit you.
Right. Okay. Right. Thank you. Thank you for that detail, the answer, Rohana and Suraj as well. So, Suraj, there's another question that I want to point to you from the audience, and I would like a short answer for this. What are the current industry standards, best practices for page load in the front end? And the server side memory and CPU computation thresholds. So basically, a quick answer, very quick answer on what sort of maybe for a place where you can refer it so that they can go back and refer all these standards, or something on a quick answer on that before we move into other questions, Suraj?
Yeah. So one thing is like I know this may be a question from someone who knows about the project, web page loading and all, maybe the application. Okay, so when someone asks about front end, what is the timing we are expecting? That means it includes all the network round trip plus client side rendering part. Okay, so if you are talking about that, industry best practices, like there, it depends on your product even, because that we can't put everything into one umbrella. So basically 5 seconds is kind of a response time we are looking at, and sometimes there are situations we are looking at 3 seconds as well. Okay, but everything based on what type of feature you are looking at, because you all know when we are searching for, when we do a search, it needs more time than doing an update. Likewise, based on that feature also it will get changed. And if I quickly switch to the other side, like what is the thresholds and threshold for the memory and CPU, that also I can't give umbrella answer for that, but the thing is usually, when if it is CPU goes beyond 60%, 70%, that is alarming. Okay. But actually when in our testing, we should not target for that. In production, yes, we have to keep our alerts there, but we should be looking at kind of a 40% level CPU, and in the memory also, we should be looking at, 50 to the 50% or something below that, because in production, what things you experience is going to be different than performance environment, because of the environment changes and the data difference and the different types of scenarios are coming in. But short answer to this one is like, based on the feature, it will get changed response time what we expected from the front end, but technically we can think of 3 seconds, 5 seconds, and see in performance, for the performance testing wise, we can keep our KPIs as 40% for the CPU and memory 50%.
Right. Okay. Cool. Right now, I would like to move to some of the questions that we plan to talk about, and this time I would like to point the discussion or the question to you, Dilhan. Now, we were talking about a lot of practices, things that we can do, and the benefits of performance engineering. Dilhan, would you like to share some experience on success stories? So, when you adapted the performance engineering practice, I know that you have adapted it. So, can you share some success stories quickly to talk, so that we can see that this is in real life as well, not just theories or documentations?
Yeah. So what we have identified as Janit, like we have evolved with these practices in the last 5 years at Cisco, and between our organizations, and what we have realized that we have done something really great, which is actually giving business assurance to our users, right? So with as you know, I mean, at a very abstract level, Cisco does warehousing, right, in terms of delivery of food to all hospitality, hotels and restaurants. So if you look at that change end to end, right, order to your cash delivery, right, what we have done is we have done performance in these separate subsystems and tied certain end-to-end performance together as well. And then the outcome has been really fascinating, Janit, over the years. That just imagine a Cisco truck driver going into a restaurant. I see this daily, right? And they unloading stuff and using all these handheld devices and applications do that. We have seen an improvement in how they do their deliveries, and which will enable them to do it faster, because for them, if they have to kind of worry about the application load, because they have to unload and undock everything by themselves. And sometimes when you park at a very busy location, you can't be worried about application. So we have seen benefits coming to the front facing operating person of our company, which gives them enabling them to kind of do applications very easily through our warehousing solutions and routing and unloading solutions. So that is one thing I have seen over the past. So experience of the end-to-end flow improving overall. And then we have obviously seen our consumers or the B2C customers improving their ordering mechanisms as well, through a lot of investment we have done in engineering that, right, with additional performance aspects as well. So we've seen that benefit. I'm not saying it's at the optimum. We are continuously improving upon it, but that gives a good confidence when your customers and your frontline workers can easily order and get things done. So that's few stuff from my lessons learned, Janit. It is true. It really helps out.
So basically, which means that performance engineering definitely brings values to the business and to the bottom line of the whatever the business application that we are working with, right?
Yeah, and the frontline worker.
Yeah, of course. The people, the consumers, are the actual business consumers. So basically, which means that these things are not concepts or just documentation or article in web, but if you really use it, this performance engineering is a practice that we can use it for real benefits of the the organization that you are working with. I think thank you for that actual example. With that, I would like to move to Rohana and talk about Rohana now. In from the development perspective, we talked about adding few thinking about certain aspect of development and doing certain additional activities and taking some for example left shift where development and designing and architecture there will be some involvement. So by doing all these activities, will there be an impact to the deadline of the project, Rohana?
So it depends how you define a deadline, right? And typically what happens is you define deadlines and you end up not being able to meet those deadlines when you have problems towards end of your cycle. So a definition of deadline is a very vague thing in my mind, because it needs to be fit for production, whatever it is, right? And that's the deadline. It's not a time-based thing in practice. However, applying some of these will take some toll from your delivery process, but then again it will you will be able to reap the benefit at the end of the exercise. Now, for example, another way, like it's really important how you start communicating about the required performance and at what stage you are paying your attention to that in convincing the leadership and the management, right? And it cannot be a surprise that you come and tell, okay, we need to do a performance testing before going to the production towards end of the development, right? It needs to be a target at the beginning and then distribute that work throughout your release cycle or throughout your sprint iteration. So that way there will be some additional thing, and these are things you can't compromise. Sometimes actually you can compromise on certain functionalities thinking that it will be implemented later on, but when it comes to performance, especially in enterprise, even in simple applications that has a large penetration, performance is going to be even more important than small functionalities. So I feel like it's important to absorb these engineering practices, and it will have some impact your time. It's always time, people, and scope and all that. So still, I think this is very critical. Having that mindset with all the stakeholders will help absorbing that, and we've done that. And some of our critical applications, we specifically focus the performance, and we spend probably a couple of sprints figuring out what is the right architecture. And we've been able to convince the management of the benefits and the value addition to that in the overall process.
Right.
So we should just talk about the deadlines, but see whether it's a priority for you. I'm sure it's a priority for many of the organizations today.
So basically, rather you find some problem latter part of the work that you do and try to go back and do some rework. Do it upfront so that rework can be reduced, so that definitely it will be beneficial in the long run as a practice. Right.
Exactly.
Right. Right, Ron. So now I would like to point the discussion to Suraj. On the same line, from the quality engineering perspective, were there? I mean, since we talked about it, it is beneficial. And definitely there will be more work to be done. From the quality engine perspective, will there be more work to be done beforehand? A very quick answer to that question, because if you can need to do that, then you need to plan it out for a smooth delivery, right?
Correct. Yeah, right. So definitely there's an impact for the deadline, but it depends of the maturity of that project for the performance engineering situation. Okay, so if it is a project where you have all performance engineering practice and everything is there, there will be no, I would say like there's a minimal impact. But suppose you are trying to introduce performance engineering, okay, or either like you are trying to introduce that in middle of the project delivery situation, right? That means there are more works come into the picture. There are more analysis coming into the picture. Sometimes you have to try multiple, solutions. to come up with the best optimal solution for that. Okay, so those will definitely going to add impact your deadline. But the thing we should not forget, we are the production. If anything goes out with bad performance, right? If application get crashed, okay, these are real world scenarios, right? Companies lose money in millions, sometimes in billions. Okay, if suppose in Black Friday, okay, everything you have planned to sell can't be done because of your website went down. So that type of real world scenarios are there. Because of that, we have to look into the advantage we are going to have. Like usually we tell like ROI, right? We have to look into the ROI, then we have to decide what type of trade-off we are talking about. Then you have to take the decision.
Right. Cool. And audience, I know that some of the questions are coming from in the URL, the Q&A URL that we have given. I also like to give an opportunity for one of you to speak and ask the question from the panel directly. Please raise your hand, and then I will direct the question to you. Until someone is coming up with a question, I would like to bring the
I think someone raised their hand.
Sorry.
Ruchira.
Hello.
Hi, Ruchira. We can hear you.
Yes, I'm using WebEx for the first time. I don't know how to enable video. So.
That's fine, Ruchira.
That's fine.
Okay. I was listening to the earlier person, and what he was suggesting was that there are, situations where people lose millions of dollars, or whatever, and to avoid that, it seems like the DevOps approach of continuously evolving the higher level of reliability within the systems and to reducing risk in individual components. So this is more like the cloud native approaches of development all the way to DevOps can only handle that. If you just try to do performance improvements in terms of speed and stuff, that's a different one. But so I was wondering what you include inside of the scope of performance. Is it reliability inside of it or outside of it?
Right. Thanks for the question, Ruchira. Anybody like to take the question and answer that?
My take on that is reliability is highly depend on the performance of the application, right? So these two go hand in hand. A lot of the time, if you see instabilities in your production, the root cause can point to the performance. So I'm thinking those two go together, and having performance engineering practices will greatly enhance the reliability of your system as well, because it makes your system more lighter, it makes your system more scalable. And Ruchira mentioned about the DevOps practices, cloud native applications. Those are great tools we can use, but having this performance focus will make applications light enough so that you can utilize even those tools very effectively.
I have a small extension to the same question, which is if you're dealing with monoliths or moving to microservices or designing with microservices from the first place, like this whole large Netflix example is there. They had taken 7 years to move from monolith to microservices. But the interesting part would be there is no clear agreement on how a new development should move, whether they should start with microservices first or that they will do the monolith to get to some point and then break it down, kind of thing. Is that outside the scope of this conversation or not?
No, I would, yeah. So let me, add something, Rohan. Okay.
Yeah.
So Ruchira, yeah. So since you talked about, actually, I will take this opportunity because there were some of the things we tried to cover in next question, but let me combine this. Okay. So yeah, you talked about Netflix and you talked about cloud and all. Okay. So let me map this with my real world, task that I have done on. Okay, so when you're talking like reliability, okay, when you talk about reliability, we should be able to rely on that application, right? Suppose our application has a configured to auto spin up when the load is the load comes to the application goes up, right? Then if there's automatically goes up, we now, in our performance engineering and testing activities, we have to see, okay, when things are spin up and the load getting distributed among those instances, okay, whether it will be handling that properly. If not, we need to see what happened. We need to drill down and see what went wrong. That is one thing. And you talked about monolithic applications to microservices and all. Yes, nowadays we are mainly focusing on microservices, and right, even now, rather than infrastructure as a service, we are talking about the platform as a service. So we may be using a pure cloud foundry, or we may be using Kubernetes and all. Okay, so then we are talking, when we go to microservices performance testing, then we can, even before we go, we have a complete product. Okay, we can test once you are releasing one microservice. We can test for that specific microservice in all the aspects, like in response time wise, and we can check whether we are talking about endurance test, like we are running for long hours and checking for the memory and all. And there are some kind of things we check in that one. And like in Netflix, you might have you might know, I guess, since you talk about Netflix, there's a testing they have done, like we call kiosk monkey. Kiosk test they did, like using kiosk monkey approach, right? Like we are during our performance testing, we are suddenly dropping the instances, or it may be suddenly dropping the memory or reducing the memory. We are doing some changes and we see how it handled. Likewise, all these things, and we are we are checking and validating before it goes to production. Likewise, we can certify. When we talk about performance testing, it is not about the response time. It's about how much we can rely on that product, right? So I think I believe you were there when I was talking about the using certifying a bat for the Chris Gale, so Jazuri, right? When our master blatters are about to go and hit for the ball, okay, maybe Akhtar is bowling or maybe Malinga is bowling, right? Then our bat has to should be able to handle that whatever the balls comes in, and we should be able to continuously use that. Likewise, our application should be able to handle everything related to performance perspective very well. So I think, I hope I covered few aspects you asked.
Fine. Just one final note. When I look at a system, I look at it from a top down and bottom up, right? Bottom when you're trying to, for example, if you're doing whatever company's systems, when you look at it from a top level point of view, how does the pieces, larger pieces of the jigsaw fit together, is a top down view. Bottom up view means you have different microservices or something like that, and you build it up, right? You need both views. And I don't know whether, I mean, when you say perf up or performance side of things, whether you sort of divorce yourself from the top down, which is a mild mistake. If you do that, you have to integrate the two, look at it from a holistic view, and then expand inside out.
Right? Yeah, Ruchir. So that's we this is not only a one session. We are going to be continuously going to talk about so many things in our future ones as well. Okay, and we are talking about all the areas, because we are going to talk about real world scenarios that we are working top to bottom top. There are different ways we have to think about it, and definitely I know we want you to join in our future sessions, and we can discuss about that. Thank you for the questions.
Thank you, Ruchir, for your question. And I think since we talked about few more about the DevOps and all, I would like to point the question to Dilhan, because I know Dilhan is driving DevOps initiative within the organization. I think he has some idea about DevOps. So performance engineering, DevOps, how it goes together, Dilhan. Can you share some thoughts on that?
Yeah, Janit, and I'm just looking at some of the questions as well, trying to relate and give
yes,
our audience
there are questions regarding DevOps
as well.
Yes.
Yeah, so ideally, one thing, guys, if you're starting up or if you're in existing organization or startup, again, this will be hard a little bit, but try not to differentiate the two life cycles, right? Do not have like a separate life cycle for performance and then another development cycle, because that will be an anti-pattern. Again, I say this with caution. If you have an existing application and your team is not in a DevOps manner and you're having a lot of legacy application, yes, please do keep it separate and try to merge later. But if you're starting out new, try to have one pipeline or a one development cycle to do that. That's a recommendation for new applications. So when you do that, with DevOps, I think what we could do is shift left and shift right, right? So I think when we say shift left, get to the development level, the IDE level, how we can improve performance. So try to do these things. Look at static code analysis, right? That is like, as example, SonarQube. If you're a startup or anything, you can get the community edition free, right? Integrate that to your development cycle. See how you can figure out performance issues at the start. If you really look at that will help. Look at dynamic code profiling with your development. See, how these are the things that accumulate and you capture in production, right? So shift left as much as you can there, right? And then think about, if you're using automation like Selenium and all that, try to, if you want to, cut off time through the pipeline, see how we can use the Selenium scripts to generate the performance script. These things are things that we have done here as well, because then it basically cuts the entire time of JMeter scripting, right? So think about that, shifting left, try to have that in the pipeline is one suggestion. And the second thing is look at the right, shift right, look at the visualization of your CPU, or get those stats and see what it is, right? Do the monitoring, use an application, open source or something like Datadog or whatever, and then check your incidents. Go and check all these incidents that you have. Maybe we have done this in the past, like we looked at it, and most of the root causes are due to availability, scalability, and all that. So think about that. And then, as Suraj alluded to, look at this chaos engineering. Again, we are experimenting it right now. We have certain challenges with it. We are looking at certain tools. That should be also like this thing with this microservices architecture that we are going into, because some of these performance also sometimes you might not be able to replicate. So look at a chaos platform. There are open source tools. Again, you have tools to purchase as well. Do that. Try to disrupt and see where it goes. So those are a few things, Janet, from a DevOps point of view, we can look at and think about that pipeline, single pipeline where we can execute everything. Again, it's very tough, guys. Like, it's not that you can do it in a few months. It has to have that mindset, and it will take time. So we say this, we have struggled, have a lot of mistakes, problems, and come here. So that's to be noted as well. So just want to briefly update, Janet, few things that our audience can do to start with.
Right. So which means highlight is that we maintain one pipeline rather than multiple pipeline, and also we need to think about left shift as well as shift right? Both side of that, just development as well as the production, so that we can do proactive approach in order to reduce some of the problems or incidents that we might face regarding performance, right?
Yeah, Janet, one small thing, context matters, right? When I say this, it may be a brand new scenario, but if you have a legacy application, sometimes what I just said might not be applicable. So context matters. So just wanted to call that out as well.
Got it. So with that, I would like open, since we talked about tools in the previous question and this question as well, I would like to start with Suraj. Can you tell us some of the tools that we can use at different levels based on your experience? We don't need to go into detail and try to explain what the tool is, but just very high level about, okay, there are tools like that, so that the audience can take those tools name and they can do some researches and see how we can how they can incorporate into their development practices. So Suraj, over to you to mention few tools.
Yeah, so I need to take some time because this is kind of a very important question. Okay, so let me, everybody, whoever taking notes and everybody think through what I'm saying. Okay, just focus on what areas I'm talking about. Okay, so one thing is we have to generate load. Okay, that means we need to have a performance testing tool, maybe a JMeter, maybe so. Okay, with the category I'm playing the tool. Okay, so that means we need to have a tool to generate the load. So it's going to be maybe open source, right? It can be a JMeter one, or it can be a Gatling or something. Or we are talking about the load runner, the number one tool we have most of the time. And okay, so that is about generating the load. Then we are talking about in the client side, you are profiling and see how long it has taken for the the JavaScript processing, how long it has taken to render the application and all. For that, we can use any browser developer tool that we have, or we can use something like Wislow, or we can use, Dynatrace something, single user testing one, like us, we can check. And if you are talking about, and so these are the tools we are dealing. Okay, then we are talking about, okay, monitor backend. Okay, so that server side, we can, we can monitor the behaviors like, CPU, memory, and additional, there are so many stuff we can check, like, if it is IIS application, we can talk about Perf because that is already available. And if you're talking about Linux servers and all, we may be able to use some Inmon or, the top command or anything. Other than that, actually, we can talk about bigger tools like, App Dynamics, Dynatrace. There are many tools, like particularly talking about the open source one, we can talk about, I think we can talk about NetJuicy, we can configure. And also, what else? Then network side, we need to check, right, how much bandwidth being utilized, and what is the impact of it. So sometimes maybe a tool like App Dynamics or something we can use to get some of the information, but if we need, we can go over to like, Wireshark or something to monitor that one. And also then we are talking about the other tools like, for profiling, code profiling. Okay, so we are talking about using a J profile or the profile of the .NET application, or like sometimes if you take the dumps, it's a dump, heat dump, then you are talking about tool like IBM Analyze or something to analyze all these. So I main thing you have to focus. Okay, I talked about the different categories, and I share you some of the tools that I have been using. Okay, so you can think through in that aspect, because when you're talking about performance engineering, you have to deal with all these tools plus extra. I would say like that.
Right. So basically, for different level, different types of activities, we have different types of tools, as well as we have commercial tools, we have open source tools. So if you are a startup where you start small, maybe you can start with open source tools. But you are enterprise where you establish more, maybe you can go for a license tool, right, Suraj? But matters is that we have different types of tool throughout the cycle of the development.
Correct. There are stack of tools that you can talk about, but when you're taking decision, like we have to, we have to assess based on our objective.
Right. Okay. With that, I would like to touch upon.
Sorry to interrupt.
Robert.
I need to just expand on Suraj's answer. Like
Sure.
tools definitely is a great way to identify these issues. I think what is important, especially from developers and engineers' perspective, is to understand those bottlenecks by using the tools and taking that learning forward, right? Understanding, for example, if your query is slow, why you need to not only fix that query, but understand the theory behind that, because a lot of these solutions are probably built using various mathematical theories and various engineering theories. By looking at that, I think you can, someday you can minimize using these tools if you apply these knowledge into your day-to-day development. I think that carrying that knowledge forward is very essential, and sharing that knowledge with the rest of the groups is also very important.
Right, got it. So it's not just tool, but the practice and mindset and all, right? With that, I would like to open a new topic, because we talked about practice, we talked about tools, we talked about agile, DevOps, performance engineering, that all these things. But at the end of the day, I believe people matters a lot, because they are the people who are delivering the work in a project, right? So I like to divide the people category into two. One is the team, other one is the stakeholders and senior management, right? So if you want to go and implement performance engineering and come up with a proposal to express this and, like, get everyone's buy-in in order to start this practice. So Dilhan, I would like to point you out, because you have done already, how we can reach the senior management and stakeholders of the business, and, like, convince that this is the performance engineering is going to be adding value to the business. So how are we going to change the mindset of senior management and other stakeholders?
So again, when I answer it, I'll answer it based on maybe enterprise level or a bit large scale and a small startup, right? So from a large scale kind of setting, I think it 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 should be. I mean, given the nature of legacy applications and so many systems, subsystems, and maybe multi-vendor scenarios, I think the conversation should be sometimes how do you improve the tech debt, because some of the applications across the enterprise will not have the relevant automation, the performance coverage, right? So we might need to kind of invest on a small team initially to kind of pay that technical debt off, because you cannot expect the development team to do that because there might be a lot of gaps, right? So what you could do is, what we have also done is, we could measure these things, right, from a stats point of view. Look at matrices, right? Look at the performance coverage of each application, and also look at, as I mentioned earlier, look at the incidents and categorize the incident based on the issue root cause, right? Maybe these are all performance. So if you have these two conditions or matrices, you could easily show some of the stats and you can show how you could prevent it. So that may be a good case study to start with, to build some kind of performance testing team or testers into it, or buy a tool, or invest on a cloud infrastructure to do that. So that is one recommendation from a large scale point of view. And from a smaller point of view, I think I saw a question also, should we, if it's a startup, should we look at this from the start? Again, context matters. If you're doing a MVP and you're going to add users to it and continue to evolve the same application, my recommendation is, I think it will be good for you to show the advantages of this to management from start. And actually, sometimes it might not be a head count to do performance testing, but it might be additional time to do performance testing, right? So you might want to spend some more time in sprint to do maybe performance, or get that setup ready, or some kind of investment. So you could show those things, and at a startup you could get some time additionally to kind of do that. That's a recommendation. But if it's a POC, or if it's just you're going to throw away, you're just going to not use it, I wouldn't say just go and try to do performance, because then you're just throwing it away, right? But startups, please keep in mind that at the end of the day, you need to attract the user, and the usage matters. But then again, keep in mind, if it's not speed enough, if it's not available, if it's not uptime is less, they are not going to adapt as well, right? So keep that in mind while you build your application. So few recommendations, Janit, from my side.
So basically, they need to be present the case, so that from the business perspective, not from the technical perspective, because they are the business related people. So that we need to approach them with the business case, and then we build the technical case later, right? Right there.
Exactly. Don't go and talk like we need this JMeter or tool. Just show the stats from production, or go from.
Right. So this is now the question is the other side of that coin, right? The team. Rohan, I would like to point to you. So team consists of mainly dev and QE. From that side, how you can change the team culture to adapt a practice like that? Because without the team, how much we try it out, we can't change it, because sometimes doing a mind shift change is not easy. So based on your experience, how you turn our team from previous practice to this practice, and how did you how can we do that, Rohan?
Like I said, I think the collaboration is the main way, like how we can achieve the performance engineering, because it's not one party's job. However, something that I've observed is, like, when people get into their early stage of careers and all that, they have this division. Okay, I'm focusing only on QE area, I'm focusing on development area, and the performance is, or at least performance testing is not my interest area, right? I think we need to break those barriers and appreciate the value additions from these different people and different opinions. So I think that mindset change is really important. Another way you can build that culture is, okay, you may have seen failures of some of the projects, and timelines getting extended, and developers having to spend additional extra hours to catch up with what went wrong. So doing some retrospective thinking about what went wrong and how much if it could have been improved if we had the performance engineering. If you can do a retro and figure out the way forward, I think it's a continuous learning, right? Then again, like when it comes to POs, right? A lot of the times now there's this concept. Sometimes developers, QEs, they think the PO has to come up with these performance requirements and all that. But I think it is not only a PO and the end user that needs to specify. Developers, QEs, and other stakeholders can also be part of that that entire exercise. So yeah, it takes time. It is the experience. As the teams mature, I think people get adapted to these disciplines. It's not one day, and you take it forward, right? With newcomers joining, you take forward that that culture with you, and it's very enjoyable if you look at, right, and you get an opportunity to put your best brains together and achieve something great, not just programming and building a feature.
Got it, Rohan. So basically, it's a culture. It's not just one party, one practice. Altogether, we need to get it and try to believe in and keep on improving ourselves, because we can't just reach 100% on the first day. It will be a gradual process, and we need to have small wins each sprint that we complete. Right. Now, I would like to combine a couple of questions from the audience regarding the quality. So we talked about development, the other as a team, how we can change the culture. From the role perspective, Suraj, I would like to ask this question. The audience also, you can see that there are a couple of questions asked. What sort of a skill set that we should have from the quality engineering perspective? And also, is there a difference on what we are doing right now? For a quality engineer. Can you elaborate a bit more on that aspect, Suraj?
Okay. So this is my belief. Okay. So if there's a movie called ABCD, right? Anybody can dance, right? So likewise, what my belief is, anybody can be a performance engineer. Okay. But the thing is, you should have the right attitude, and you have to make yourself ready to do some challenging activities. Okay. So kind of because don't think that you don't know any tool at the moment, but those things can be learned. Okay. So skill set wise, what I think, try to you have to be a good, you should think like, start to think, start to believe in yourself, and try to be a quick learner, to learn any new tool. It may be for testing or analytical or this. And also try to have a R&D skill. You should be able to research, Google it, and check. You might don't know at the moment, but still you can learn so many things from the internet. So you have to ready for that. Okay. And personally, only thing you might have to improve, I believe, is like some people have some good analytical skills to drill down, go into deep, and check in the areas that is needed. Okay. If you have not improved that, with the time you can have it when you are resolving a lot of issues. Like, okay. And also other thing is, always things, domain knowledge matters. So you should be able to map the domain knowledge with the issues that you're facing, because that is the way you can combine all the code, all the practices, all the noise that you know. Okay. So when you are trying to do all these, when you're having this skill set, then this challenge, some challenges people talk about is, okay, you have to learn a lot of things. Yes, you have to learn a lot of things, but if you're ready to learn, you can do it. And the thing is, for analytical and solutioning, right? It's like think like if you put a analytical and solutioning hat, then you can analyze anything and come up with some ways of resolving that. Okay, and ready to learn from anyone. Okay, so because you can learn so many things from there. Even suppose you are an architect, or suppose you are maybe a head of the company, still you can learn something from an intern, right? So you have to have mindset. Okay, so because those are the main thing I want to touch base, as well as some new responsibilities will be you have to own performance. Anything goes wrong in the production, you need to own that. You have to be accountable for that. Okay, you have to be ready for that. Okay, and then try to set up all required KPIs and everything for using any tool. Okay, and you may have to run multiple tests, and you may have to do some tweaks in the environment by yourself. Be ready for that. Those things are the key things I wanted to share with the team, whoever wants to start performance engineering.
Right. So basically, a tool is just one aspect, but there are other skills that you need to focus on, analytical
Exactly.
and the
Yeah.
research abilities. So it's a conscious thought process that you need to put it. So anybody can be a performer, any can be an expert on the area, and it's a collective approach as well as a team. With that, I want to ask a couple of. One question from Rohan. This is connected with the audience question as well. When we are thinking of performance engineering, does the application matter, or what type of application that we should adhere performance engineering? Can we apply to any application that we develop, whether it's a AI app or whether it's a legacy application or a microservice, whatever we do for a long-term perspective, can we adapt performance engineering practice?
Yeah, I think you can hear me, no?
Yes.
So I think performance matters irrespective of what type of application. What sort of audiences will be impacted will be different, right? For example, for a mobile or a web app, we are targeting about the consumer, so we need to keep the engagement with the system and feel your application is performant, so it matters there. Then there can be other applications like AI and all that, right, which is running behind the scene and doing a lot of calculations and all of that. Then probably what matters is having optimized processing power, so you don't spend money on processing, right? If your algorithm is optimized, then it'll have benefit in the time you spend in processing. And when you store data, right, optimizing that matters because it costs you money. So I think having a performant application always matters in multiple ways, not only thinking about the end users, but even processing, scaling your application and maintenance and continuous evolution of that application, all can be benefited through having better performing application. However, applying some of these principles may be different from application to application. For example, if you have a legacy application, I think some people had asked some question, audience had asked some questions also. You may not have full control of the application. It may be a legacy application, but providing a key business functionality. Still, I think modern day tools allow you to at least to dig into more insights like the CPU, memory, and analyze memory footprints and see how things happen and tweak some of the configurations, right, of the system. So with that way, you can still apply some of these engineering practices even in legacy applications.
Yeah.
Also with this auto scaling and all the cloud infrastructure view, certain applications which are very legacy, which was never probably meant to be performance engineered, is still being able to perform at a very good level with by adapting some of those techniques. So it's applicable
Right.
to whatever the application
So depending on the context and the application, we need to understand the basics of the application and the practice, and then we need to adapt it and see how it can be successful. And it is an iterative approach, right? Right. So with that, I would like to ask the last question from the panel about a future. What will be the future of performance engineering, and any key point that you want to highlight as a wind up answer for you? So I would like to start with the person who started the discussion, Suraj. So I would like to start the final set of questions from you, Suraj. So based on your experience, the future or any key point that you want to highlight as the last answer from you for today, Suraj.
Okay. So I would put things in this way. Okay. So regardless of the application, technology or the domain, okay, we have to deliver a quality product. When you're talking about the quality product, performance matters. Okay, and that should be able to sustain longer period. Okay, when I mentioned those words, there are different type of testing. We are talking about the behind the scene and engineering task. Okay, so in order to deliver a better application quality product in performance perspective, and also has to be a good product, end user like to experience well. Okay, so to do that job, to deliver a good product in performance perspective, okay, performance engineering helps us better to do this job, do that job better than performance testing, because we're talking about so many things, so many solutions, so many analytical things that we are talking about. Okay, in future, like you will not in future, actually already some companies already started this, right? So there are SRE, there are terms you might have heard, SRE culture, there are DevOps culture, everything comes, but those are integrated monitoring performance and doing performance tweaks, fixes. Okay, so always, if you think about having a good product, like this is for everybody, not only for the engineering people. Okay, if you are planning to have a quality product, okay, make sure you integrate your industry level performance engineering practices. Okay, and try to be matured with that. Okay, like by using all these things, you can have a very good product which perform very well. And with that saying, actually, I thank everybody for participation and listening to us. And let us know if you need to know anything. I think there are a couple of ways you can reach out to us. Thank you.
Sure. Rohan, final comment for the day. Any key points that we should take away?
Yeah, if you look at, I think the performance is becoming a given thing, right? I mean, it's not going to be anything explicit in the future, and people expect this performance from whatever the digital experiences they want, right? So that triggers another requirement for our engineers to be more mindful about the performance and know about that. A lot of the time, our engineers focus on programming and building certain features and all of that. They don't get into the details of this programming, like how to optimize your parameters for your programming language, and how do you manage your heap, and how do you optimize your data load, and what are the different protocols that you can use. So there are a lot of things that enlightens you to do a better job. So I think the performance engineering is going to be a very interesting subject for top high-end engineers, as well as top high-end quality engineers as well, because nowadays I think manual, like we are not looking at manual testers. We need testers who are capable of doing automations and also performance testing in general, and knowing that knowledge, scripting knowledge, and ability to compete and work together with a group of engineers, group of programmers. I think the distinction between QE engineers, developers also becoming very less now, because everyone is contributing to the success of the team, and performance engineering is a great way to collaborate the knowledge between these different groups. So have that as a tool in your skill set, and it's going to be well sorted after skill even today, and it's only going to go up in time to come.
Okay.
With that, I want to thank everyone for being with us for about an hour or a little bit more, and hopefully we'll have a lot more sessions that will enlighten all of us with regard to performance engineering.
Yes, Rohan. Dilhan, final remarks from you for the day, Dilhan.
Yeah, Janit. So I'll just as key takeaways, I'll kind of share like as a think like a. I mean, I know there are engineers, quality engineers, and maybe managers, leaders in this call. So think like a full stack, right? Think how we can be a full stack dev or a full stack QE, right? Think of that entire life cycle. think from that pipeline aspect, right? How do you build that? So learn about the build tools like Jenkins, Go CD, or whatever you do today. Think about the performance tools that we discuss, right? JMeter to load runner or anything. I prefer open source, but then again, think about that. Think about monitoring APM, right? We spoke about a lot of things like Dynatrace, Datadog, or any open source as well. Think about alerting, things like Slack to Jira to, we use Grafana to monitor things and all that, right? Think about how you can run your performance in a cloud in an elastic way, because you don't have to keep, instances. You can have like things like containers to, spin up things. So think about that cloud aspect. Think about networking, infrastructure, compute as a whole. One recommendation is learn about cloud computing if you're not doing that today, right? And basically think about all this and the data that is being stored out there, right? So in the future, Janit, I feel with all this data and with the data where we can get predictability with certain things like machine learning and then the use of AI techniques, I feel that might be the future, and keep that doorway to learning about that as well, because that's I would say a key takeaway for, I guess, the Sri Lankan industry. We need to think full stack. We need to think building great engineers who can think about it. And also, guys, it doesn't mean that you have to basically know every language or scripting and all that. Even you have a very good high level knowledge of this will really benefit your career as well. So a few tips, guys. Think about that aspect, because as you heard from everyone, performance engineering is a must, right? So to help that journey, please think about these aspects that I mentioned about, and especially with the cloud and data. Learn about those things as well, because that will matter in the future. We might use the data to predict how the performance goes as well. So think about those. And thank you, Janit, and the team, Cisco Labs team, for organizing this, and everyone. You all have stayed a little bit late as well. Appreciate it. If there are any questions, reach out to us. We are really happy to help you on your career journey. Thank you. Thank you, Janit. Over to you.
Thank you, Dilhan, Rohan, Suraj, for spending time 1.5 hours and preparing for the session as well. Personally, I have learned a lot. I'm sure that the audience have learned a lot as well, because you were sharing your experience and new concepts and practices. I think it was a really great session. I want to thank you again for your time and the effort that you put in to share your knowledge and all. I'm sure that we will reach to you again, and I'm sure that you will really, again, you will accept our invitation to come back and talk about more on your experience with the audience again in future sessions. With that, I would like to thank the audience as well. They have patiently listened and they be engaged with us and all the questions and all. I know there are certain questions that we couldn't answer. So please reach us using Cisco Labs' social media or the meetup page for Perf Up, and put those questions in. And then also you can reach to the speakers as well and put your questions in. And whenever and however we can, we will try to answer those questions for you, because we believe that together we need to go this journey and we need to get up for the future. So we are ready to help you out, and we will be coming to you to have more sessions with expert knowledge from other people as well. So stay tuned for future sessions as well. And I would like to thank the organizing committee. They have done a tremendous job, a volunteer job from them, and they have went the extra mile to make sure that we have a smooth session today. And I think we had the session smoothly, and everybody worked towards that. And I want to thank everyone. So please keep connecting with us using social media and the page site, and suggest future topics that you want to discuss with you. And if you have more questions, and if you want us separate a Q&A session, we can organize as well, totally focusing on the audience Q&A session as well. So likewise, we can organize future sessions based on your need. And also, I'm sure that organizing team will share a feedback form. Please, when you get the feedback form, fill it. It will be great help to understand your thoughts, and we can incorporate, because this is a brand new initiative because we thought that this is the right time. We need to talk about performance engineering because it's going to be a mandatory topic and mandatory practice that we need to adhere as a Sri Lankan IT industry. And with that, again, thank you very much, Cisco Labs and LMD as the media partner, and Cisco Labs for empowering this because it really helped the industry. And thank you very much for these two organizations. And again, thank you very much, speakers. Thanks all, and good night, good evening, and good day, and stay safe. See you soon.